Acids, bases, salts, and pH level. Acids, bases, and salts are inorganic substances that break up or dissociate in solution or water to form charged particles or ions. The positive ions are called cations, and the negatively charged ions are called anions. Before we look at acids, bases, and salts, let's take a look at water. A water molecule is made up of an oxygen atom and two hydrogen atoms that are covalently bonded or share electrons with the oxygen atom. However, the electrons are not shared equally within the molecule, as they have a higher probability of being found closer to the nucleus of the oxygen atom, giving that end a slightly negative charge. So the hydrogen atom's end of the molecule will have a slightly positive charge. These charged ends weakly attach the positive end of one water molecule to the negative end of an adjacent water molecule. This attraction or bonding is called a hydrogen bond. Sometimes this attraction of a hydrogen atom of one water molecule to another molecule becomes so strong that it actually detaches from its original molecule and attaches to the other water molecule. So this yields a hydronium or H3O positive ion and a hydroxide or OH negative ion. Also, water molecules continually dissociate to form positive hydrogen ions and negative hydroxide ions. This is a reversible reaction as noted by the formula H2O double arrow or reversible reaction, positive hydrogen ion and negative hydroxide ion. The actual amount of these positive H3O or hydrogen ions in water is actually very, very small. To make things easier to understand, we will consider the positive H3O ion and the positive hydrogen ion as one and the same. So, in pure water, the amount of positive hydrogen ions and negative OH ions is the same. Now for acids. An acid is any substance that when added to an aqueous solution or water will release a hydrogen ion or increase the concentration of hydrogen ions. So, how strong an acid is depends on the amount of hydrogen ions produced. For instance, hydrochloric acid, or HCl, which is a hydrogen atom bonded to a chlorine atom, when added to solution or water, will dissociate or break down into negative chlorine ions and positive hydrogen ions. Hydrochloric acid is a strong acid as it completely dissociates in water. Now for bases. Bases are essentially the opposites of acids in that they shift the hydrogen ion hydroxide ion balance in favor of the negative hydroxide ion. This can be done by increasing the number of hydroxide ions or decreasing the number of hydrogen ions. For instance, sodium hydroxide, or NaOH, will break down or dissociate into positive Na ions and negative OH ions. So the balance is shifted in favor of the negative hydroxide ions, meaning sodium hydroxide is a base. Bases can also be strong or weak depending on how well they break apart. Sodium hydroxide is a strong base. This brings us next to the pH scale, which is basically an abbreviation for the phrase power of hydrogen. So the pH scale measures the concentration of hydrogen ions of a solution, or it measures how acidic or basic a substance is. As the amount of positive hydrogen ions increases, the pH goes down, and the solution becomes more acidic. As the amount of positive hydrogen ions decreases, the pH goes up, and the solution becomes more basic. On a pH scale, a pH of 7 means the solution is neutral, or the number of positive hydrogen ions equals the number of negative hydroxide or OH ions. A pH of less than 7 means the solution is more acidic or more hydrogen ions than hydroxide ions. And a pH of greater than 7 means the solution is more basic or more hydroxide ions than hydrogen ions. On the scale, hydrochloric acid, which we mentioned earlier and is produced in the stomach, is at the most acidic end, having a pH of 0. Vinegar has a pH of 3, coffee has a pH of 5, and pure water has a pH of 7, making it neutral. On the opposite end, sodium hydroxide, which we mentioned earlier, is at the most basic or alkaline end, having a pH of 14. Ammonia has a pH of about 11, and baking soda has a pH of between 8 and 9. Now we can look at salts. A salt is a chemical compound formed from the reaction of an acid with a base. So hydrochloric acid, HCl, can interact with sodium hydroxide, NaOH, a base, and form sodium chloride, NaCl, and water, H2O. Salts break apart or dissociate in a solution of water to form positive and negative ions, which make them important for certain body functions. There are many different salts that are important in the body, such as sodium chloride, or NaCl, and potassium chloride, or KCl. These salts are often most effective as charged ions or atoms in solution, as the positively charged potassium ion and the positively charged sodium ion are required for muscle contraction. And that be the basics on acids, bases, salts, and pH level.